Just number 1 and 2. And it has 3 parts. You need to do part A, B, and C.
You're working. Your number 1. Part A.
So, ladies and gentlemen, make sure that you do all the pieces for 1. It's A, B, and C.
We don't know equations. But we don't know equations.
So, another word for equation is a number sentence. Okay? You have to fill in the blank. What times what equals what? We did this work together. This is an example of an equation of a number sentence. If you have time, you can do number 3. We've only got 1 more minute left. So you can do number 3 if you're waiting on time. You must do 1 and 2. You can do number 3.
I'm already good. No, you have to do number 3 if you have time.
This was.
Make sure you're
So this is 5 groups of 2. 1, 2, 3, 4, 5. And there's 2 in each row. 2, 4, 6, 8, 10. You want 6 groups of 2. In fact, what do you need to do to this one to show that 6 groups of 2?
That's but is that 2 note? Remember? Your array goes
And
by
then what would
rows,
your number sentence be?
not columns.
That other way around. Okay. 2. So how many groups of 2 do you have?
You have 12 dots there, my friend?
Is it a Jordan? Okay, so how many groups of 2?
What's the word?
1, 2, 3, 4, 5, 6. So draw an array that shows 2 groups of 6 or 6 groups of 2. Which one is it?
You should have 6.
Oh, that's wrong.
I need 6 groups of 2.
It must be a
That shows 2.
You finished the only one that you found? Very good.
Alright,
Okay, may I have eyes up in 1, 2, 3, 3, 2, 1. Thank you for being good listeners. Okay, so I want to end our work today. Let's just go to number 2. We learned about the commutative property of multiplication. This is the work we did today. And somebody called it the flip it, the turnaround. Okay, turnaround fact. So how is this similar to the commutative property of addition? And here in this pink box, this is addition. How is it similar? Turn to your elbow partner. How is it similar? Is it Malcolm? So Malcolm, how is it similar? So compare the blue box to the pink box. We talked about with multiplication, if you turn those factors around, you get the same product. Is that true?
Are they the same?
How do you know? What's the same? 4 plus 3 equals 7. And then what's the bottom number sentence?
I need help.
Oh, so they use different numbers. So that's my next question is what else is different? Okay, may I have eyes?
I need help.
Eyes up. So what's similar about both of these? They're both called the commutative property. One's addition, one's multiplication. So what's similar about them? What's similar about them? Ooh, you switch what? What do you switch? Tell me more, you're on the right track. Tell me more. What do you switch? What did we switch here? The numbers, and in multiplication we call these factors. I flipped them. Is that true for this? Okay. I have the 4 and the 3, and did I flip them? What do we notice about our answers? What do we notice about the products? What do we notice about the sums in both of those problems?
Both of them, one has 16 of both, and one has 7 of both.
So they have the same answer. Doesn't matter the order, we get the same answer, okay? Whether it's addition or multiplication. What's different? How are these different? We've already called out how they're the same, but how are those two properties different? What's different in those number sentences besides the numbers? That's obvious.
One is a teen and the other is just a regular.
Okay, so different size.
Yeah.
So it depends on what we're doing. But what's different about these?
It's not the same.
Okay, so different numbers. Okay, I'm going to circle it. Does that tell us to do the same thing?
Yes.
No! What's the operation in the pink box? This tells you to do what? Okay, so addition. Okay, to combine them. What's the operation here?
Multiplication.
Multiplication. Okay, so there's your difference. Okay, last thing that I'm going to ask of you, and then maybe we could, if we don't want to exit now, we can exit. We can keep